Okay. Hello, everyone. First of all, I would like to thank the organizing committee members for inviting me to give this keynote. And after discussing with General Chair, Dr. Danda Rawat, we decided that if I provided an overview of NSF size and related programs, that would be informative and beneficial for the workshop attendees. I'm a SATC program director. I'll talk about what SATC is. It's a program within NSF. NSF, the National Science Foundation, its mission is to promote the progress of science, to advance the national health, prosperity, and welfare, as well as to look at things to secure the national defense. And this is achieved through many different research and education activities that NSF champions in all fields of science and engineering. That includes biological sciences, engineering, mathematical and physical sciences, and so forth. I'm part of computer and information science and engineering. That's the directorate that focuses on all the activities related to computer science and related fields. NSF supports all areas of fundamental research. In fact, one of the things we emphasize is we are here to support curiosity-driven research. All foundational basic research are of interest for NSF. And if you look at NSF's support to research and educational activities as percentage of total federal funding that goes to academic research, we can see that NSF channels about 25% of that federal funding, tax dollars. And if you look at computer science number, it's 87%. So most of computer science and information science related innovations have been funded through NSF. I'll give a quick overview of SIZE. SIZE stands for Computer and Information Science and Engineering, and it addresses all national priorities within computing field. So right now, national priorities are listed here: AI, big data and robotics, cybersecurity, microelectronics and manufacturing, quantum information sciences, and so forth. And I would like to note that computer science education is high priority in the US. Advanced wireless research has been there for quite some time as high priority area, which is aligned with, in some way, this workshop. SIZE has 3 divisions. The first one is Office of Advanced Cyber Infrastructure. The goal of OAC is to support basic research and educational activities that focus on development, acquisition, and provision of state-of-the-art cyber infrastructure resources like high-performance computing infrastructures and so forth. And in general, all cyber infrastructure that gears towards advancing science and engineering broadly. Second division is Computing and Communication Foundations. And the focus here is basic computing and communication theory, algorithm design, architectural design of computers and software, and so forth. And the third one is Computer and Network Systems. This is the division where I am housed. Here, the focus is in inventing new computing and networking technologies. The fourth one is Information and Intelligence Systems. Here, the focus is on research and education activities that relates to understanding the interrelated roles of people, computers, and information, and to increase our ability to understand data. And here we also focus on intelligent systems. So any AI-related activities typically comes from IIS. SATC is a program that is managed from SIZE. It's a secure and trustworthy cyberspace program. It's a flagship research program within NSF that really focuses on foundational and highly interdisciplinary research in all aspects of security and privacy. We actually view cybersecurity and privacy as highly socio-technical problem, and it is also representative of interest from many directorates within NSF. Although it is housed in SISE, we have participation from education and human resources, engineering, social, behavioral and economic sciences, as well as maths and physical sciences. At any time, we typically have about 1,000 active awards. Typical annual budget is 80 million. Since SATC was created, we have given out 700 million, about that amount in research funding. Before SATC, there used to be cyber trust, trusted computing programs, and so forth, which focused on cybersecurity and privacy areas. So if you consider all these programs, NSF has funded about over 1.1 billion in that space. And these are various topics within security and privacy that are listed in the solicitation. Hardware, software, different aspects of security and privacy, human-centric computing, networking, that includes wired and wireless environment, and so forth, are all part of the topics. And this is just to guide the potential investigators. It's not the exhaustive list. If it is not there, that doesn't mean it's not included. So as a proposal writer, you have to just make case that it is relevant to SATC program. And this is our interdisciplinary staff. If you look at some names, you can see it's someone is from IIS, another is from CCF, SBE, and so on. So this is representative of different program directors representing different directorates within NSF, giving us a very highly interdisciplinary team. The goal of SATC is to support research and education program. So we have 3 designations where you can apply. First is core. Essentially, here you are looking at foundational research proposals. So if you have some foundational basic research that you want to carry out in security and privacy, you would submit to core track. And then you have transition to practice, TTP, that's basically focused on supporting development, implementation, and deployment-oriented activities. And then we also have educational track, basically to support cybersecurity education and workforce development related research, the proposals. There's no deadline, so you submit whenever you are ready. You can submit up to 4 proposals, 2 proposals in core, 1 in TTP, and 1 in EDU track. You can submit at different levels. So we have small category, which is up to 600K, up to 3 years, medium, up to 1.2 million, up to 4 years. And educational track allows supporting up to 400K for 3 years. In some spatial, highly collaborative proposals, you could request up to 500K. And then career programs are there, CRII programs are there. These are actually not specific to SATC, but I'll talk about that also. SATC Frontiers are biggest investment from SATC. It's a center scale project. We try to support very, very ambitious and very transformative ideas that includes highly multidisciplinary approaches that brings huge teams together to work on far-reaching research explorations that can really catalyze the area, that really stimulate significant research and educational outcomes. And frontier projects are up to 10 million for 5 years. These are some of the frontier projects that have been supported. The two in the boxes, data flow in internet and IoT for consumer environments. These are currently active frontier projects. And these are somewhat relevant to this workshop also, because it's touching on broad space of IoT enabled world. So if you look at frontier, the first frontier, its title is Protecting Personal Data Flow on the Internet. So it's looking at this highly converged, highly interconnected world where we have IoT devices and internet and all kinds of computing artifacts connected. And the proposal is looking at theoretical issues, privacy issues, utility versus privacy trade-off, fairness issues, looking at system security aspects, devices, networks, servers, edge devices, mobile devices, web environment, IoT devices, and so forth. So it's looking at the entire converged environment, system requirements, measurements, and also looking at what kind of policies, especially from privacy aspect, become critical here. As we are talking about flow of information, it naturally brings the information that also has privacy sensitive data. So these are all highly ambitious goals that they have that brings technical as well as non-technical issues to be looked at in a very coordinated way. The second one is called SPLICE, Security and Privacy in the Life Cycle of IoT for Consumer Environments. So this also brings IoT ecosystem from a very specific domain, consumer environments. And it is looking at the entire life cycle, design, development, deployment, direction, discovery, as well as decommissioning of these consumer IoT devices, smart things. So overall goal is addressing security, privacy risk of these smart things by looking at human, social, and technological scope of these security and privacy challenges. And the focus is smart homes across a wide range of activities, or looking at residential stakeholders, owners, occupants, renters, visitors, and domestic workers, and so forth. So it's a very specific focus, but looking at it in a much more technical, sociological aspect, and so forth. Another program which is directly relevant to this workshop is Resilient and Intelligent Next Generation System, RINGS program. So this is a new program. We are currently in the process of finalizing decisions on the first round of submissions. And the key objectives of RINGS program is to really, again, support fundamental research. That's one of the key reason NSF exists, to support fundamental research. But here we also want to accelerate the translation of this research into new technologies, also to form a strong and effective cross-sector research community. So next generation system, we really want to build strong community around the research topic relevant to this. And also the focus here is to emphasize inbuilt resilience as the primary consideration when we are designing next generation system. And the time frame and budget, currently we're looking at awarding up to 40 awards, each up to 1 million per award. And the duration expected is 3 years for each proposal. Participation-wise, this program is supported by many industries and other federal agencies, US government agencies. Actually, we have 9 industry players who join hands to support this program, and all contributed different amounts to total to $40 million that is being funded currently. And the structure for this program is, it's typical NSF academic research program. It also includes test-based access. There's also working group that are being formed. And also it's trying to support a virtual organization that brings together the rings-related researchers together. And for the program proposals, the solicitation defines research vectors, and you have to follow the requirements with regards to addressing these research vectors. And there are 2 groups: resilient network systems and enabling technologies. So these are the partners. You can see Google, IBM, Intel, Microsoft, the big players are all supporting this effort, and in many cases contributing some funding as well. And NSF is the key coordinator for this program, and it's mainly the NSF program, but with support from all the partners. Again, the goal here is to elevate and really emphasize resilience as the primary consideration when you are thinking of next generation systems. And how do we look at resilience? It's essentially resistance and or high tolerance to attacks, cybersecurity or privacy attacks, or resistance or resilience against failures and service disruptions that may occur because of many variety of reasons, and focused on identifying the root causes. Or it may be gracefully managing degradation of service and adaptability when resource availability is impacted by highly disruptive events. Or it could focus on resilience in computational capabilities that is spread across many different distributed, highly heterogeneous resources. So that's the key focus or the goal of this program. And research vectors are defined vertically and horizontally. So we're looking at proposals focused on applications such as augmented reality that merge physical and virtual worlds, or designing algorithms, for instance, related to spectrum sharing, resource optimization and management. We're looking at proposals that may be looking at device to edge to cloud continuum. What are the challenges there? Or we could be looking at proposals that focus on hardware, radio frequency and mixed signal circuits, antenna designs, and so forth. And along these different focus areas, we are interested on looking at adaptability aspect, end-to-end security challenges. How do we devise autonomy in these solutions and so forth? So these are the vectors. I'll quickly touch on this. There are 2 groups identified: resilient network systems, group A, and enabling technologies. And so the first group, group A, here the focus is resilience in the network, as well as any associated service and computational architecture. So we are interested in looking at full stack security. We're interested in looking at intelligence and adaptability capabilities, which also includes, in general, AI components, machine learning components, including privacy preserving machine learning. It could be focused on autonomy, zero trust autonomous networks, safe AI, and so forth. Or it could include any other resiliency components that is not identified in the solicitation. All you need to do is to provide appropriate justification. And enabling technologies could be any component or full-fledged technologies that span from circuits to edge to cloud and so forth. So new radio approaches, spectrum utilization technologies, edge to cloud continuum and challenges there. It could be network, service or network slicing and so forth. Many technologies could be part of this. And of course, digital, physical, virtual worlds, how do we integrate them, and how next-G system, uh, what kind of challenges exist to achieving that kind of integration. Other programs include National AI Research Institutes. This is quite broad, not specific to the workshop theme, but it could be, right? So it's broad topic areas, and typically there are teams created. For instance, team one was intelligent agents for next generation cybersecurity. This is the current set of teams. And here you could have 5G and beyond related cybersecurity issues where you deploy intelligent agents to address the challenges and so forth. So these are some of the themes that are currently the interest of this program. Other opportunities, we just had a new call for internet measurement research, and that's broadly defined, so somewhat related to this workshop. Here we are looking at how to foster research, looking at ways to understand the internet. So measurement is the key area. And so we're looking at methods, methodologies to do the measurement. What are the tools, privacy aware, secure tools that help in addressing the internet measurement related challenges, how to capture, how to curate, and so forth. And overall infrastructure that helps in curating the internet measurement data sets and allowing different types of experiments in that. Okay, so that's quite relevant to this workshop, but there are other typical solicitations like designing accountable software systems. And here the DAS program is basically interested in looking at software components and then also looking at how it relates to addressing legal policy requirements. And while this is broad enough, it could also relate to next-G related challenges, right? So if you have IoT, 5G enabled environment, and if you need to deploy software components, how do you address accountability and how do you address legal issues that are required to be, complied with within that ecosystem? We also had a DCL, their colleague letter, to solicit some proposals focused on enabling secure and trustworthy cyberspace, size and SB interdisciplinary collaboration. So the cybersecurity and privacy areas are becoming more and more multidisciplinary in nature, and we want to foster more collaborations between computing experts and social behavioral and economic scientists to really come up with better solutions. So these are some other opportunities. There's also cyber physical systems program. That's pretty big program that focuses on supporting research areas that touch on cyber physical system related components. So transportation, energy, and industrial automation, these are some application domains, and where 5G and next generation net systems could be key components, right? So this is another huge program that you could look at. Smart and connected communities, and of course 5G and beyond are some of our next-G system-enabled environment is what we are looking forward to, and how smart and connected communities can be created through these technologies are of interest here. We also have smart health and biomedical research in the era of AI and advanced data science. Again, this somehow also relates to looking at all aspects of computing, communication, and information technologies, from hardware, sensor design, or sensors that could be embedded into our human bodies and so forth. And so all aspects that focus on health as well as biomedical research are of interest here. So deadline is mentioned. So the next deadline in this list is for 2022. So please check the website, NSF website, to see the actual deadline that you may be interested in submitting. I also wanted to mention Industry University Cooperative Research Center. This is a program that helps develop, long-term partnerships among industry, academia, and government. So this is initial funding provided by NSF if you have plans to develop these industry university cooperative centers. So there are different phases. I won't go into detail. Planning grant, phase 1, phase 2, and for each phase, there's a requirement from the center side. For example, bringing industrial partners and engaging them in research and so forth in a particular way. So this is another program that you might want to consider. There are other programs that focus on really supporting infrastructure building activities, large-scale infrastructure. So mid-scale research infrastructure, one is basically to support cyber infrastructure development projects that addresses community or national scale computational and data-intensive science and engineering research. Okay, so it could be for planning, for the design of mid-scale RI1 up to 6 million, and then mid-scale RI2 is up to 100 million. So depending on what infrastructure you're talking about, it would fit to in one or the other of this program. There's also a much bigger program called MREFC. I forgot the full form, but that's much beyond 100 million. So this is just to give a broad overview of different types of programs that you might see that may be something that you want to look at. So it could be core research, but then also we also have programs that focus on infrastructure building and so on. I did want to mention about career program. So this is focused on faculty early career development. This is considered to be NSF's most prestigious awards for the junior faculty. Okay, so this is basically awarding junior faculty who really exemplify the role of teachers, scholars through research and education activities. So we look for outstanding research, something they have already done, and outstanding research in the agenda they propose, excellent education, and so on. So that's a highly regarded program that we support. It supports up to 5 years for one PI, so it's one PI proposal, minimum 400K, but typically it's 500 or a little over 500. And here we are looking for 5-year research agenda that helps this junior faculty member to become a leader in that space. So we really look for ambitious 5-year project, and also look at how well integrated the research agenda proposed is with regards to the educational mission. Okay, so look at well integrated research and education component as well. Another early faculty program is Computing Research Initiative program. This is for people who are even in the earlier stage than ones who would typically submit career proposal. Okay, And here the goal is to contribute to growth and development of future generation of scientists and engineers that will dedicate their research activities in science areas. Basic goal of CRII is to support early career academicians who really do not have good access to organizational or other resources. So if you do not have adequate resources to carry out the research, or if you do not have PhD students that you can support, that the department is also not able to provide you through departmental support, then it's CRII proposal that you should really look at. Okay, so the goal is to say, if not many universities have adequate resources to support the research, to support a PhD student who can work with the PIs. So it provides opportunity for any individual who is in the first academic position after postdoc to recruit and mentor their first students. Okay, so this is really to help really brand new, typically faculty members who do not have adequate funding to support graduate students or to carry out research through adequate resource sets needed for the research. And it's a small amount, but it's typically there to try to give support for graduate students. With that, I conclude, and I'm part of SATC. You can always get updates from SATC program if you join this mailing list. And if you have any questions, please do not hesitate to send me an email. Okay, so with that, I thank you all. Hope you have a successful workshop.